All right, so our lesson today on section 2.7 is on using ratios to model some situations, talking about unit rates, setting up some proportions, and using the cross products property, also known as cross multiplying, to solve those proportions. So couple things this is used for. So we could talk about a little bit about scale drawings. That would be like your typical blueprints where you have a smaller version of something drawn on paper. Now, of course, you want to make sure that the drawing on the paper is really reflecting, the right dimensions and proportions of the actual building or structure. So that's why it's important to use scaling and proportions when you do that. A scale model is the same idea, just something three-dimensional versus on a piece of paper. And scales are also used in other parts of everyday life, such as scaling a recipe. Maybe you want to take a recipe that makes enough servings for 4 people, and you want to increase that to serve more people, or vice versa. So first of all, let's go over solving some proportions using that cross product property. So when we do cross product property, we're essentially just multiplying across. Now, when we do that, we want to take the 20 and multiply it by the x in this particular situation, which would be 20x. And then you still have your equal sign. And on the other side of your equal sign, you would multiply the 8 by the 35. In this case, that would give you 280. And just continue solving it using your normal inverse operations. So in this case, you would end up with x equals 14. Now we're taking a look at just a couple examples. Okay, so we take a look at number 1. 126 is across the diagonally across from the x, so you have 126x. And then if you multiply 15 times 210, you would get 3,150. And then you would just divide both sides by the 126, leaving you with x equals 25. Now, number 2 and 3, you'll notice that you have these binomials here. And a binomial is two terms that are separated by an addition or subtraction sign. So you're going to have to put those in parentheses when you do your cross multiplying. So on one side of your equal sign, you will have 21y. And again, it doesn't matter which side you want to put that on, the left or the right. And the other side, you're going to be multiplying 9 times the expression y plus 8, so it's going to go in parentheses. Now you would use that distributive property, so you'll have 9y plus 72, and then you would continue solving for y. So getting all of our variables on one side, that leaves us with 72 equals 12y, dividing by 12, and then of course, y would equal 6. All right, and then our third example is another one of these types of situations. So I'm going to put my z minus 5 in the parentheses so that when I distribute my 28, it's going to get multiplied to both the z and the minus 5. And then on the other side of my equal sign, I'm going to have the 24z. So now when I distribute, I have 28z minus 140. And now I want to get all my z's on one side. So for me, that would makes sense to move the 28 over, since the only thing on the right now is terms that have a z. And that's going to give me a negative 4z. And then I'm going to divide both sides by that negative 4 so that I can get the z alone. And that is going to give me an answer of 35. So z would equal 35. Now we use cross products to solve proportions, and proportions are made up of rates or ratios. Now, one of the most important rates we can talk about is what a unit rate is. So a unit rate is how much for one given unit. So when we use these in our everyday life, we use things about like how much does one item cost? Like when you're in a grocery store, you might see something broken down into a unit rate using ounces or something like that. We also use unit rate with our cars, right? How many miles per gallon or how many miles per hour are we driving? Also, if you think about if you have a job and you're getting paid hourly, how many dollars are you getting per hour. Those would all be considered unit rates. And unit rates are great because they can compare two things that maybe are different, and you can kind of get an equal playing field to find out, what a good comparison is of those things. It can also help you find information that you need if you don't have all of the information. You need to scale it. So finding the unit rate, the first thing that I think about is a lot of times the word per is used. So for example, if you said like how many miles per gallon, or here how many miles in 1 hour. So whatever's coming after that per, so to speak, would indicate that that's what's being divided. So your line or your slash, okay, is really a division sign. So if I said dollars per hour, I know the dollars would go on top and hours would go on the bottom. If I was saying miles per gallon, then I would know miles are on top and gallons are on the bottom. So that's what you have to keep in mind, because once you set up that ratio or that rate, you're just dividing it out. So if it costs $2 for 5 cans of dog food, how much does 1 can cost, right? So if we want this to be a 1, we're saying how much money per 1 can. So what is that amount? So you just have to divide 2 divided by 5 and you'll get 40 cents. So what that means is it's going to be 40 cents per 1 can. So let's take a look at the next one. You get paid $121.50 for working 18 hours. So we're looking at dollars per hour. So the dollars are going to go on the top and the hours are going to go on the bottom, and then you can just divide that out. And when you divide that out on a calculator, most likely you're going to get $6.75 per hour. All right, so let's take a look at number 3. It costs $1.39 for 1.5 quarts of juice. What is the price for 1 quart? So then you know this is going to go on the bottom. So it's going to be dollars per quarts. So we have $1.39 on the top divided by 1.5 or 1.5 quarts. And that's going to give you 93 cents if you round to the nearest hundredth. So 93 cents per quart. Okay, you need 6 ounces for 2.5 servings. How many ounces do you need for 1 serving? So because that's the unit, that's going to go on the bottom. So we know that our ounces would go on the top and our servings would go on the bottom. So we have 6 ounces and 2.5 servings. So we're just going to divide that on our calculator, and you're going to end up with 2.4 ounces per serving. Now notice this time, instead of writing the word per, I just wrote the symbol for ounces slash, and then I abbreviated servings. With dollars and things like that, you don't have to write out a word on the top because the dollar sign symbolizes that it's money. But for this, I had 2 different units, so I made that comparison using that little slash, which is the same thing as per, or indicating division. All right, so our next one, it takes 4 hours to fly 1,200 miles. What speed is the plane flying at? So we have to think about our 2 units here. We have hours and miles. Would a speed be miles per hour or hours per mile? So hopefully you remembered that it would be miles per hour. And so we know that the miles would go on top and the hours would go on the bottom. So now we can put in the information. We have 1,200 miles per 4 hours. So if we simply divide that, we will get 300 miles per hour. Now, this is another example of how you could abbreviate those units. We could have wrote the word miles, the word per, P-E-R, the word hours. We could have done M/H, or in this case, MPH, indicating miles per hour. You hiked 52 miles in 3 days. So this time we're doing miles per day. So 52 miles in 3 days would divide out to 17.33 miles per day. Or you could even write 17 1/3 miles per day. Okay, notice I used two different examples of how we could write the units. I also did it in fractions and decimals. I can swim 2 miles in 40 minutes. How long does it take me to swim 1 mile? So we've been used to putting the miles on the top, but this is an example where the miles are going to go on the bottom because the unit here is 1 mile. So that tells me that the miles are going to go on the bottom because it says how long for 1 mile. So that would mean that the minutes is going to have to go on the top. So 40 minutes for 2 miles. And if we divide that, we would get 20 minutes per mile. So we want to know what is our rate there. Mom drove 69 kilometers in 3/4 of an hour. What's her average speed? So again, you have to decide what is the speed. In this case, it would be kilometers per hour. So 69 kilometers divided by 3/4 of an hour. If you want to put it as a decimal, you could. And when you divide that out, you get 92. In this case, it would be kilometers per hour. Okay, number 9. It costs $65.85 for 3 tickets. What's the unit rate? So in this case, $65.85 for 3 tickets. If I divide that out, I will get my price per ticket. So $21.95 per ticket. So that would be my unit rate. You were paid $75.15 after working 9 hours. What is our unit rate? And I'm guessing it's dollars per hour. It's a very common unit rate. So $75 per 9 hours. We divide that out and we would get $8.35 per hour. Okay, so using these rates when we solve proportions. Okay, so typically what's going to happen is we're going to look at a question. We can set up the ratio that they give us. So for example, here it costs $5 for 2 sandwiches is a ratio. How many sandwiches can I buy for $22.50? So this time we're not concerned about finding the unit rate, but we want to use this ratio that we know to help us find out how many sandwiches could we get for a larger sum of money. Now, the key is when you set up these ratios, of course, you want them to be equal. So if you're spending $5 for 2 sandwiches, you should be spending a proportional amount for more sandwiches. So when you set these up, the key is that whatever you put on the top of the first ratio, whatever unit you use there, needs to stay consistent and be on the top of the second unit. So I call that the top to bottom method, and this is kind of how I typically will set them up. But you'll notice if you write them in any of these other ways, it would still calculate correctly. So for example, if I had $5 for 2 sandwiches, that's my ratio on the one side here, then the money is also going to go on the top when I set up the right side of my proportion because I put money on the top on the left side. And then the number of sandwiches is on the bottom on the left, so that will also be my answer on the bottom on the right. If you did it the way the second box is showing, it would still work out correctly when you cross multiplied, but you would have different units in different locations as long as you stay consistent. So for example, a bag of large breed dog food recommends feeding a dog 3 cups of food for every 40 pounds of body weight. A dog weighs 98 pounds. How much food should the dog be eating each day? So the first thing I usually do is look for my first ratio. So it says 3 cups of food a day for every 40 pounds. So that's this first ratio here, the 3/40. So because I put the cups of food on the top and the weight of the dog on the bottom, I'm going to have to stay consistent when I do that on the other side as well. So on the other side, I have 98 pounds. So that tells me that I'm going to have to put that 98 on the bottom since I put pounds on the bottom on the left. then you would just cross multiply from there and solve that proportion. So 40 times x, and then on the other side you would have 294 because you're multiplying the 3 and the 98, and then you're going to divide, and you will get x equals, and it's 7.35 cups of food. All right, so here's another example. A car travels 135 miles on 4 gallons of gas. So that's my first ratio. I'm just going to set it up exactly as it's written. 135 miles, 4 gallons. If you wrote 4 gallons on top and 135 miles on the bottom, it doesn't really matter as long as you stay consistent with the other side. So because my miles are on top and gallons are on the bottom, I'm going to have to use the same units on the top and the bottom on the right side. So how many gallons, that's my x going on the bottom, of gasoline will be used to travel 540 miles. That's going to have to go on the top to stay consistent with the left side of my equation. Now I'm cross multiplying. 135x equals 540 times 4 is 2160. And then I would simply just divide and get x equals 16, and of course that represents gallons in this particular problem. All right, so practicing with these proportions and cross products. So if 6 out of 8 people use a certain toothpaste, so we have 6 out of 8, so 6 is representing the users and 8 is representing the total people that were surveyed or whatnot. How many people, so how many users, out of a new total of 60,000. So 60,000 is representing a larger total, and we want to know how many users out of that value. So now we do our cross products. 8x equals 6 times 60,000, 360,000, and then we're just going to divide that by 8. And we end up with x equals 45,000. And this, I'm just going to say users of this particular product. Okay, Sam uses 4 reams of yarn to make 3 scarves. So that's my first ratio. So I have 4 reams to 3 scarves. So on my second ratio, I have to make sure reams would be on the top and scarves would be on the bottom. So they're giving us 15 scarves, so that 15 goes on the bottom. How many reams? That x is going to go on the top. Then we cross multiply. So here I would have 3x equals 4 times 15, which is 60. Divide by 3, x equals 20, and my variable that I'm looking for here is representing reams of yarn. Okay, a recipe for making corn muffins requires 1,600 grams of flour to make 40 muffins. So on the other side, then it says how many muffins can be made using 1,000 grams of flour. So I'm going to have to put that on the top since I put grams on the top on the other side, and then X amount of muffins on the bottom here. Now I'm going to cross multiply. So I have 1,600x equals 40,000 dividing by the 1,600, and x gives me 25 muffins. Mr. Hammond used 15 gallons of gas to drive 450 miles. So there's our first ratio, 15 gallons, 450 miles. Now notice normally we put miles on top of gallons, but like I said, it doesn't matter for these problems as long as you stay consistent. So now on the other side of my proportion, how far can he drive? So how many miles? I don't know, X, on a full tank of 20 gallons of gas, and I'm going to put my gallons on top because that's what was on top on the other side of my proportion. Now cross multiplying. So I have 15x equals 450 times 20 is 9,000. We divide, and we get x equals 200 miles. Okay, so you're traveling to Canada and the current exchange rate is $1.12 Canadian to $1 US. So this is actually a unit rate, $1.12 Canadian to $1 of US. If you have $250 in US money, so I have to put that on the bottom since US was on the bottom over here, how much Canadian money would you get? So we cross multiply, x times 1 is just x, and $1.12 times 250, I'll have to use my calculator, is $280, and that would be in Canadian money. Okay, a map is scaled so that 2 centimeters represents 15 kilometers. So 2 centimeters, 15 kilometers, that's my first ratio. If 2 towns are 7.9 centimeters away, that's got to go on the top because my centimeters were on top on the left. X amount of kilometers, how many are they apart? So 2x equals 15 times 7.9 is 118.5. And then we would divide that by 2, giving me an answer of 59.25. And that would be in kilometers because that's the one that we're missing. Okay. A designated hitter made 17 hits in 20 games. If he continues at that rate, how many hits will he make in 79 games? Well, games are on the bottom on the left, so I'm going to put that on the bottom on the right, and that allows me to solve for that number of hits. So 20x equals 17 times 79, which is 1343, divide by the 20. We have 67.15. Now, this may be a situation where you kind of need to round it because you can't have a decimal of a, oh, it's a hit, I'm sorry, of a hit. We're finding out how many hits. You can't have like a part of a hit. It either is or it isn't. So it'd be 67 hits about. Okay, a 9-foot tree casts a 21-foot shadow. So we have the tree and then we have the shadow. So how tall is a tree that has a 17-foot shadow? 21x equals 9 times 17, which is 153. Divide it by that 21. So x equals 7.285, which would round to 29, and this would be feet, and that would be, or I'd say foot tall tree. Oops. Okay. Dave eats 4 slices of pizza every 5 days, so 4 slices every 5 days. At this rate, how many slices? So x slices in 60 days. Cross multiplying, 5x equals 4 times 60 is 240. And then we're going to divide the 240 by 5. So 240 divided by 5, and we get 48 slices. A lot of pizza. All right, a photo that is 3.5 inches wide. So that's the one dimension, and it's 5 inches long. We're going to enlarge it so that it's now 13 inches wide. So what is that length? So 3.5x equals 5 times 13, 65. And now we're dividing that by the 3.5. So x equals 0.57, and this would be inches long. So probably about 18.5. All right, Tim's brownie recipe calls for 2 squares of chocolate, 2 3/4 cup of flour. So I'm going to say 2 squares for 0.75 cups. He wants to make as much as possible, so he uses all 6.5 squares of chocolate. So that's going to be 6.5 squares. Notice I'm putting on the top to X cups of flour. So when possible, you can definitely change fractions into decimals as long as they're not repeating. 6.5 times 0.75, 4.875, and then we're going to divide that by 2. And we're left with 2.4375. So I'm going to round it 2.44 cups of flour. At a concert sold out in 6 hours. A total of this many tickets were sold. So in 6 hours, they sold 9,570 tickets. At what rate did they sell? Well, we want to know hours per ticket or tickets per hour. So see how we're finding that unit rate. So we want to actually switch this up this time. It's not going to be necessarily set up as a proportion. So we have 9,570 tickets, and that's in 6 hours. So we can just simply divide that like we did with unit rate and get our answer. 9,570 divided by 6, and it's 1,595 tickets per hour. Now, if you did it cross multiplying and you set it up this way, you would still be able to get the answer. It just said at what rate though, and you might have been like, oh, I don't know, what rate? So whenever it says that, you know that the hours would be 1, and you cross multiply, and you'd end up just dividing anyway. So you could still get the answer that way, but it's just easier to do as a unit rate because you just have to do division. Okay, on a recent survey of 20 students in this age group, it showed 17 of them had an iPod. So 17 people had the iPod out of 20 total. If there are 1219 total students, so it's going on the bottom, how many would you expect to have an iPod? So 20x equals 1219 times 17, 20,723. I'm going to divide by 20, and I get approximately 1,036.15, but of course you can't have a decimal of a person, so it'd be 1,036 students, I guess it was. I was going to write people, but students. All right. On a model train, a tank car is 3.75 inches long. An actual tank car is 50 feet, so that's that relationship there. If a model engine is 5.2 inches, what would be the actual length? So 3.75x equals 50 times 5.2, which is 260, dividing by that 375 or 3.75 there. And we're at 69 and 0.3 repeating, so it's actually 69 1/3, and it would be feet. It took about 144 hours for 2 men to cross the ocean in a hot air balloon, which was a distance of 3318.2. Now notice they're throwing in the 2 men to throw you off. What was their average speed? Well, average speed, okay, this is a unit rate, so you'd probably want to do miles per hour, so you're going to switch those around. So you're going to do the 3318.2 divided by the 144.25. And I have 23.00 miles per hour. And finally, number 16, if an acceptable tip on a $16 meal is $3. So this is the meal and this is the tip. What would be an acceptable tip on a $63 meal? So 16x equals 63 times 3, which is 189. Dividing that by the 16, and we get x equals $11.81. All right, so the last thing on the last page here is just using scales on blueprints, which is really just the same thing we just did. If you have a scale of 2 inches to 15 feet, then you would have a drawing of 14.5 inches. How many feet would that be in reality? You set up your proportion, cross multiply, and solve it. So here, for example, a blueprint has a scale of 3 centimeters to 5 meters. So that is the one we're going to use for all of these. And then you would put in the centimeters that they're giving you and calculate the meters. So here we would have 3x equals 5 times 4.5, which is 22.5. Dividing that by 3. Sorry. And we have x equals 7.5 meters. We're going to use that same scale for the other two problems as well. So 3 to 5 equals, centimeters are on top. So over here again, 3 over 5, centimeters are on top. And we cross multiply. So 3x equals 40.5. Divide by 3. And I have x equals 13.5 meters. And for the last one, I would have 3x equals 3. And of course, for this one, I would just get x equals 1 meter.